Good day. Today I'm going to show you how to find the equations of the cubic graph. There are two ways to find the equations of the cubic graph. The first one is the x-intercept form, using the x-intercept form of the cubic graph to find the equation of the cubic graph. The second method is using the derivative to find the equations of the cubic graph. In this particular video, I am dealing with the second part. If you want to know how to use the x-intercept form of the cubic graph to find the equation of the cubic graph, the video is at the end of this video. It can also be found right here at the suggested video. There are 4 methods which we'll deal with in this particular video. After you have learned all 4 methods, you'll be equipped with enough skills to be able to get the equation of the cubic graph using the derivative. And in combination with the first video, you'll be equipped with enough skills to be able to find the equation of the cubic graph in any situation. Alright, let's begin. So we're given a cubic graph with 2 unknowns. So we've got 2 unknowns A and B. And we're told that f passes through 1:10. And the gradient of the tangent is -6 when x is 2. Show that A is equals to -1 and B is equals to -3. So first of all, we're given a point. We're told that f passes through this point. And the second information is that we're given the gradient of the tangent. So the gradient of the tangent is very important. You have to understand gradient of the tangent. So what do we mean? So first of all, you have to memorize the fact that first derivative represents the gradient of the tangent. It's very important. So this is very important to memorize, especially for those who are my students. Please memorize that first derivative means gradient of the tangent at a point. So first derivative means gradient of the tangent. Let me give you a clear understanding of tangent. Alright, let me show you a clear understanding of tangents. So if we draw a tangent right at this point, x is equals to -3, a tangent is a line that touches the graph once, so it's going to look something like this. So this is going to be the tangent at x is equals to -3. And if we check the gradient of this tangent, this gradient is positive because the graph is increasing from left to right. So if you follow the graph with your fingers moving from left to right, you realize that your finger is going up, so you know that the graph is increasing. But if the graph is decreasing from left to right, then it has got a negative gradient, so the gradient will be negative. But if the graph is increasing from left to right, it will have a positive gradient. So in this case, the gradient can be m is equals to 5 because it's a positive gradient, so I just took any value. So let's just assume that the gradient is positive 5. And then if we draw a tangent at x is equals to -2, it's going to be a horizontal tangent because it's at a turning point. And if a tangent is horizontal, it means it's neither increasing nor is it decreasing. So we can therefore say that the gradient of this tangent is 0 because it's neither increasing nor decreasing. That is why it's called the stationary point. That is why your turning points are also called the stationary point. That is why whenever you find your turning point or your stationary point, you always say the first derivative is equals to 0. The reason why we say that is because the gradient of the tangent is 0 at the turning point. If we draw another tangent, for instance, let's say at x is equals to -1, it's going to be something like this. So we're going to have a decreasing tangent. So we can assume that the gradient here will be something like -5. So that is what they mean when they say first derivative. First derivative means the gradient at a point. At different points, there are different tangents that can be drawn in the graph. If they say the first derivative when x is equals to -2, they're saying what is the gradient of the tangent when x is equals to -2. And we know that this is going to be 0 because it has got a horizontal tangent there. So that's what they mean. First derivative just means the gradient of the tangent. If they say what is the gradient of the tangent, if they say what is the first derivative when x is equals to -1, they're saying what is the gradient of the tangent when x is equals to -1, and that will be -5. So first derivative always represents the gradient of the tangent at that point. So please memorize this. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. So, with that understanding, we can proceed. So we're told that f passes through this point, and the gradient of the tangent, which is the first derivative, so we're told the gradient of the tangent, which is the first derivative, is -6. So it means the value of the first derivative is -6 because the gradient of the tangent is -6 when x is equals to 2, meaning that the gradient of the tangent at 2 is equals to -6, or the gradient of the tangent when x is equal to 2 is -6. So we've got this information, and we also have this information. So just with this information and this information, we can begin to solve. So what we'll do is that we'll substitute this information first into the original equation, and then we'll substitute this information into the derivative of this equation because this pertains to the first derivative, and we'll solve simultaneously. So we have to solve simultaneously because we've got two unknowns. So let's begin. All right, with this information, we can begin to solve. So what we need is this part. So with this, we can substitute it into the original equation. So let's substitute the first part. So we already know that the y value is 10. So we're going to say 10 is equals to a, and the x value is 1. So it's going to be 3, and then we're going to have this squared, then we're going to have 18 into 1 minus 4. Let's simplify this equation further. So we're going to have a, then this is just going to be a. Okay, fine, I meant this is 10 and this is just going to be a, and then this side is going to be b, and then we're going to have 18 minus 4. All right, if we take 18 to the other side, we're going to have 10 minus 18, which will be minus 8. If we take 4 to the other side, we're going to end up having minus 8 plus 4, which will be minus 4. So therefore, a plus b is equals to minus 4. So this is what we have so far. So we've got a plus b equals to minus 4. So this is going to be our first equation. So now we're going to create our second equation by substituting into the derivative. But first we have to create the derivative formula. So let's create the derivative. So far we know that it's going to be f prime x is equals to, so this part is going to become 3ax squared. And then this part is going to become plus 2bx. And then this part is going to become plus 18. And of course, this part just disappears. So let's proceed. So we have to substitute this information into the derivative. So we know that the answer of the first derivative is minus 6. So therefore, this is going to be minus 6. And then the x value is 2. So we're going to have a into 2 squared plus 2b into 2 plus 18. And then from here, let's simplify this equation further. So then we're going to have minus 6 is equals to, this is going to be 4 times 3, which will be 12. So we're going to have 12. And then this is going to end up being 4b. And then this is going to be 18. And then from there, if we take 18 to the other side, it's going to be minus 6 minus 18, which will be minus 24. And then this is going to be 12a plus 4b. We can even simplify this by dividing everything by 4 because everything is divisible by 4. We can even leave it like that. But let me just divide it by 4. So this is going to be negative 6 is equals to, then this is going to be 3a, then this is going to be b. So I have created my second equation. All right, let me rewrite the two equations that I've created. So, all right, so I've rewritten my two equations. So you can use the elimination method or the equating method or the substitution method. In this case, I'm going to use the substitution method. So I'm going to manipulate my first equation and make b the subject or the formula to create my third equation. So it's going to be b is equals to, since I take a to the other side, it's going to be minus 4 minus a. So this is my third equation. So it means that I'm going to say substitute my third equation into the unmanipulated equation, which was the second equation. And then this part is going to be, so it means that in the second equation, wherever I see b, I have to replace it with negative 4 minus a. So I'm going to write the second equation exactly the same, but wherever I see b, I'm going to replace it with minus 4 minus a. This is going to end up being minus 6 is equals to 3a, and then we're going to have minus 4 minus a because the positive does not affect anything. And then now this is going to be, so when you have 3a minus a, is going to end up being 2a. And then if we take minus 4 to the other side, minus 6 plus 4 is going to be minus 2. And then when we divide both sides, we're going to end up having a is equals to minus 1, just like the question. And in order for us to find b, we can substitute it into any one of the three information. But in this case, the easy one is obviously the one that I made, the subject to the formula, which is just the third equation. So it means that I'm going to now substitute it into the third equation. So therefore, I'm going to say minus 4 minus, so my a was minus 1 is equals to b. And then from there, this is going to end up being minus 4 plus 1, which is equals to b. So it means that b is going to be equals to minus 3, just like the question. And there we have it. Alright, here is another situation. We are given a cubic graph with two unknowns a and b, and we're told that f passes through 1 is to negative 12, and y is equals to 12x plus 8 is a tangent to f at x equals to negative 4. Find the values of a and b. So we are given a point, and we're told that this equation is a tangent to f. This question can come out in the sentence form. It can also come out in the diagrammic form. Let's take a look at the diagrammic form of it. Alright, here is the diagrammic form of it. So you are given a cubic graph and you are given a tangent. So they have to tell you that this is a tangent. So if they tell you that this is the tangent, then for you to find the equation, all you need is a point. For you to find a and b, you need a point. So you've got a point right there, which is 1 is to negative 12. And then the other information that we need is the gradient of the tangent. So all we need is the gradient of the tangent. The gradient of this graph is 2 because the straight line graph is always in the form of y is equals to mx plus c. So m always represents the gradient. So in this case, we have the gradient of the tangent already. We know that the gradient is 2. So the first derivative when x is equals to negative 4, because the x value is negative 4, is 2, because the gradient of the tangent is 2. So with these two information, we can begin to solve. Before we solve, let's deal with the sentence form of it first. So we were given this point. So we have a point 1 is to negative 12. And we are told that this equation is a tangent. So what we needed was the gradient of the tangent. That information we needed was the gradient of the tangent. So from this equation, we can say that the gradient of the tangent is 12. So therefore we can say the first derivative is 12. The value of the first derivative, which is the gradient of the tangent, is 12. So they say this is a tangent to f at x is equals to minus 4, meaning that the first derivative when x is equals to minus 4 is 12, because the gradient of the tangent at x is equals to minus 4 is 12. And just with these two information, we can begin to solve. So let's begin to solve. So we're going to substitute this information into the original graph. Therefore, we're going to have minus 12 is equals to a into 1 squared, or rather cubed, plus b into 1 squared minus 12 into 1 minus 4. And we're going to have minus 12 is equals to a plus b minus 12 minus 4. And I know minus 12 and minus 12 will just cancel. If I take this 4 to the other side, it's this negative 4 to the other side is going to become 4. Alright, you can do it anyhow. I just cancel the two. Whenever two things are the same but on the opposite sides of the equation, they will cancel. Because if one comes to the other side, they'll just cancel. So this is going to be our equation 1. And then we create equation 2 by substituting this information into the derivative. Alright, let's substitute this information into the first derivative. So we know that the first derivative we have to derive. So it's going to be f prime x is equals to 3ax squared plus 2bx minus 12. So let's substitute this information. We know that the answer of the first derivative is 12. So therefore we're going to say 12 is equals to 3a, and the x value there was -4. So then we're going to have into -4 squared plus 2b into -4 minus 12. And then from there we're going to have 12 is equals to 4 squared is 16 times 3 is 48. So we're going to have 48a. And then this side we're going to have minus 8b minus 12. And then from here, if we take this 12 to the other side, it's going to double up. It's going to be 24 is equals to 48a minus 8b. You can call this equation 2, but I'm just going to simplify it. I noticed that everything here is divisible by 8. So 24 divided by 8 is 3. And then 48 divided by 8 is 6. 8 divided by 8, of course, we're going to have 1. So this is going to be my equation 2. So using these two equations, I can use either the elimination or the substituting or the equating method. In this case, I'm going to use the substitution method. So I'm going to manipulate my first equation by taking a to the other side of the equation. So therefore, I'm going to end up having 4 minus a. So this is going to be 4 minus a is equals to b. This is going to be my equation 3. So it means that in the second equation, the unmanipulated one, which I will substitute, equation 3 into the unmanipulated equation, which was equation 2. So in equation 2, wherever I see b, I'm going to replace it with 4 minus a. So therefore, it's going to be 3 equals to 6a minus, so instead of me writing b, I'm writing 4 minus a. So let's move forward. So we're going to have 3 is equals to 6a. This is going to be minus 4 plus a. And then 6a plus a is going to be 7a. And if we take that 4 to the other side, it's going to be 4 plus 3, which will be 7. So if we divide both sides, we're going to get a is equals to 1. So we solved our a. Let's solve our b. We can substitute into any one of the three equations. We can substitute it into either equation 1 or equation 2 or equation 3. But the easiest one is equation 3 because b is already the subject of the formula. So let's proceed. So it means I'm going to end up saying 4 minus, instead of me writing a, I'm going to write 1 is equals to b. And then this is going to end up being b is equals to 3. And there we have it. I found the values of a and b, so I can therefore say a is equals to 1 and b is equals to 3. Alright, here is another example. So you are given this equation and you are given the turning point. So every time we're given the turning point, we can use the same information for the original equation and we can use the same information for the derivative. So we can use this information twofold. The reason why we can use it twofold is because we know that the first derivative at the turning point is 0. So every time you're given the turning point, you can use this information twofold. You can use it for the original graph. You can also use it for the derivative. So we know that the first derivative when x is 2 is 0. You get a mark for that. So you have to tell them that. Alright. So in this situation, whenever you're given one turning point and you're not given d, they should give you the y-intercept. Whenever they give you the y-intercept, we already know that d represents the y-intercept because usually at the straight line graph and in the parabola, c represents the y-intercept. For instance, in the straight line graph, we have y is equals to mx plus c, and c is always the y-intercept. So c is always the y-intercept. So in this case, we're going to have d as the y-intercept. In the cubic graph, d always represents the y-intercept. So we have found d, so therefore d is the y-intercept, which is minus 3. So far we have found d. So now we need to find b and c. So remember, we can use the same point for the original and the same point again for the derivative because it's the turning point. So let's start with the original first. So if we substitute 2 is to negative 35, we end up having negative 35 is equals to minus 2 into 2 cubed plus b into 2 squared plus c into 2 and minus 3. So let me rewrite this. So I have rewritten this stuff. So let's simplify this equation. So we're going to have minus 35 is equals to, this is going to be 2 cubed to this 8, which is 8 times 2 is actually 16, negative 16. So then this is going to be 4b, and this is going to be 2c minus 3. Alright, if we take this negative 3 to the other side, it's going to become negative 35 plus 3. And this is going to be negative 32. If we take 16 to the other side as well, it's going to be negative 32 plus 16. And this is going to end up being negative 24. So I'm just simplifying it. So then this is going to be 4b plus 2c. So we can leave this equation like this, or we can simplify it. And notice that everything is divisible by 2, so therefore I'm going to divide it by 2. So then this is going to be 12 is equals to 2b plus c. So that's what we have. So we have got our first equation. So remember, we can use the same point for the original and the same point again for the derivative. So let's derive this graph. So if we derive this graph, we're going to have f prime x is equals to, this is going to be negative 6x squared plus 2bx plus c. So then we have to substitute the information of this into the derivative. So already we know that at this turning point, we know that the first derivative is 0 and the x value is 2, which we have written here. So let's substitute this information into this equation. So let me rewrite this equation. Alright, so we know that the first derivative when x is 2 is equals to 0. So the first derivative when x is 2 is equals to 0. So therefore we can say the first derivative is equals to 0 when x is 2. So therefore it's going to be 6 into 2 squared plus 2b into 2 plus c. So let's proceed. Then this is going to end up being 0 is equals to, this is going to be 4 times negative 6 is 24. And this is going to end up being 4b plus c. So we can call this our equation 2. So since I've got my equation 1 and my equation 2, I can create my third equation. I can use any method, either equating or substitution or elimination. So I'm going to use substitution, therefore I'm going to create my third method. I'm going to create it by manipulating the first equation. So I'm going to take 2b to the other side of the equation. And therefore it's going to be minus 12 minus 2b is equals to c. So that is what we're going to have as our third equation. Then I'm going to say substitute my third equation into the one that I didn't manipulate, which was equation 2. And let's proceed. So I'm going to write equation 2 exactly the same, except for the fact that instead of me writing c, I'm going to write 12 minus 2b. So therefore it's going to be 4b plus 12 minus 2b, or rather negative 12 minus 2b. So then we're going to have 0 is equals to negative 24 plus 4b minus 12 minus 2b. Alright, so this is going to be 0 is equals to, so when we group this, is going to be 2b. So we're going to have 2b. And then minus 24 minus 12 is minus 36. If we take it to this side of the equation, it's going to be positive 36 is equals to 2b. And therefore we're going to have, when we divide both sides by 2, we're going to have b is equals to 18. So we can substitute it into any one of the three equations. So we have b as 18. So obviously the easiest equation to substitute it into is the third one, since c is already the subject of the formula. So therefore I'm going to write it exactly the same, except that where I see b, I put 18. So then I'm going to say minus 12 minus 2 into 18 is equals to c. Then it's going to be minus 12 minus 36 is equals to c. So this is going to end up being minus 12 minus 36 is minus 48. So c is equals to 48, negative 48. So we find the values of b and c. So therefore b is equals to 18 and C is equals to minus 48. And there we have it. Alright, here is the final example. Before we continue, I want you to be aware that this is not a realistic drawn graph. However, this example appears in the exam where you are given 2 turning points. So there is a situation where there is 1 turning point, there is another situation where there are 2 turning points. Let's proceed. So in the previous example, you were given only 1 turning point. But in this case, you are given 2 turning points. Whenever they give you 2 turning points, they are not more likely to give you the value of D. So even in the graph, you can't guess what D is. So what do you do in this case? In this particular case, whenever there's 1 turning point, they will give you the value of D. But whenever there are 2 turning points, they will not give you the value of D, because even when we derive, D will disappear. D will be a constant. We'll find D last. Just remember, when they give you 1 turning point, we'll find D first. But when they give you 2 turning points, we find D last. So when we've got 2 turning points, we know that we can use it for the derivative. So we'll use this turning point for the derivative and that for the derivative as well. So let's derive this equation. So if you derive this equation, you'll get f prime x is equals to negative 6x squared plus 2bx plus c. So this is the derived form of it. So then we have to substitute both this information. So let me rewrite this equation. Alright, so I've rewritten it down here. So by now you should know that the first derivative at the turning point is 0 because the gradient of the tangent is 0. So it is 0 as well for this turning point. So we've got the information pertaining to the first derivative for both of them. So first we're going to use this one, and then next we're going to use this one. So we know that the first derivative when x is equals to minus 2 is equals to 0. You get a mark for this. And then let's substitute that. So we're going to have 0 is equals to negative 6 into negative 2 squared plus. So we're going to have 2b into negative 2 plus c. So let's simplify this equation. So then we're going to have, this is going to become 4. So 4 times negative 6 is minus 24. And then this side is going to be minus 4b plus c. So we can call this our equation 1. Let's substitute the second information as well. So let's substitute this information as well. So we have to tell them that the first derivative when x is minus 5 is equals to 0. So the first derivative when x is equals to minus 5 is equals to 0. You get a mark for that. And then let's substitute into this formula. So then we're going to have 0 is equals to minus 6 into minus 5 squared plus 2b into minus 5 plus c. And then let's simplify the second equation. So we're going to have 0 is equals to, this is going to be minus 150. And then this side we're going to end up having minus 10. So minus 10b plus c. So this is going to be my equation 2. So I've got both my equations. I've got my equation 1 and my equation 2. So equation 1, equation 2. So I'm going to manipulate the first one. So I'm going to make it the subject of formula by taking this one and this one to the other side of the equation. So therefore I'm going to have 24 plus 4b is equals to c. This is going to be my equation 3. And then from then onwards, I can now say substitute. So I'm going to say substitute equation 3 into the one that I did not manipulate, which was equation 2. So I'm going to write equation 2 exactly the same way as it was, but instead of c, so instead of me writing c, I'm going to write this stuff. So then it's going to be plus 24 plus 4b. I'm not putting brackets because it's not going to affect this. So if I take this and this, it's going to be minus 10 plus 4, which is minus 6. And then so far we're going to have minus 150 plus 124, which should be minus 126. So if I take it to the other side, it's gonna be positive 126. Yep, positive 126. So if I divide both sides by negative 6, I'm gonna end up having, so I know I know that 120 is divisible by 6 to give me 20, and 6 is divisible by 6 to give me 1. So therefore my answer is gonna be 21, negative 21. So I found B. Now let me find C. So I'm obviously going to substitute it into the third formula. So it means it's going to be 24 plus 4, and instead of me writing B, I'm going to write minus 21 equals to C. So then this is going to be 24, then this is going to be minus 84 is equals to C. So this is obviously going to be minus 60. So I found C. C is equals to minus 60. And there we have it. So we've got B and C, but we didn't yet get D. 60. So we've got B and C. So we need to get D. So far, we found out that B was negative 21. Therefore, B is equals to negative 21. Therefore, C is equals to negative 60. So we need to find D. We have found our B, we have found our C. So how do we find D? Well, in this case, it's very simple. We can substitute any one of the points. We can substitute either this point or this point to find D. And it's that simple. So let's substitute. So then I'm gonna choose this point. All right, I have rewritten the equation to make things simpler. So we're substituting this point. So therefore we're gonna have minus 7 is equals to minus 2 into minus 2 cubed minus 21 into minus 2 squared minus 60 into minus 2 plus D. So we have to just simplify the numbers. It's gonna be minus 7 is equals to, so this is gonna be minus 8. Minus 8 times 2 is gonna be positive 16, and then this side is gonna be minus 84. And then this side is going to be plus. So we're going to have plus 120. So this is what we have so far. So let's proceed. Then this is going to end up being this still minus 7. So when you look at this stuff, 120 minus 80, I know it's going to be 40. Minus 4 is going to be 36. 36 plus 16, it's going to be 52. So therefore we have 52. Plus D. Then we have to take this to the other side. So let's take it to the other side. So therefore we're going to have minus 7 minus 52 is equals to D. Then this is going to be minus 7 minus 52, which will be minus 59. So there we have it. Minus 59 is equals to D. So just remember, whenever you're given one turning point, you'll be given D. So D is the y-intercept. So you'll be given the value of D. But whenever you're given two turning points, you are less likely to be given D. But you don't have to worry about it. The minute we derive, because D is a constant, D is going to disappear. So in the derivative, D will not matter. So you'll use the derivative for this information and for this information as well. And then when you're done, you just substitute any one of the 2 points to find D. Alright, if you enjoyed my video, please like my video and subscribe to my channel. And please share my videos. And any questions you've got or any video you want me to create, please comment below.